I know I'm gonna be the man who gets drunk next to you. And if I heaver, yeah, I know I'm gonna be the man who's heavering to you. But I would walk 500 miles and I would walk 500 more to be the man who walked 1,000 miles to fall down at your door when I'm walking.
For the subsystem breakdown of the project, we have Logan in charge of powering the sensors, microcontroller, and antenna. We have Dylan in charge of the microcontroller, which receives data from the sensors and communicates it via a Bluetooth antenna. We have Sydney in charge of the data analysis of the data itself, and we have Jason in charge of the phone app, making an easy-to-see visual representation of the data. The power and sensors subsystem is broken down into one 1000 mAh 3.7 volt battery, which is charged by a micro USB charger. It is then connected through a switch to the rest of the components, which are in parallel. 3.7 volts is connected to the Bluetooth antenna and microcontroller. A voltage regulator boosts the voltage to 5 volts for each of the 3 op amps, and a separate voltage regulator steps down the voltage to 1.25 volts for each of the 6 sensors. On the left, we have the recommended FlexiForce circuit design. I modified it to calibrate for a 200-pound individual and only max out the output when all of their weight was put on the heel or one specific part of the foot. I was able to integrate 6 of these circuits into 3 dual op amps in order to save space. On the right, we have the measured voltage outputs as weight increases, and that it acts in a very linear fashion, which we were very happy to see, although there is some exponential curve. The voltage output of the sensors start at about 1.9 volts, which is offset by the microcontroller. And you can see as I press on the heel, the output to the voltage increases to however hard I can press. Here you can see the charger working properly and the switch turning on the system, which is indicated by the flashing red light, and the battery under the board, which can last up to 10 hours at a calculated 100 milliamps per hour maximum load.
The microcontroller portion is comprised of a microcontroller that converts analog signals from the weight sensors into decimal values. It then transmits this data to the phone application using a Bluetooth module, in this case an HC06. And since this is going on top of a shoe, the design needed to be relatively small and lightweight. This was all coded using Code Composer Studio in C language. Once an analog signal is detected at an ADC pin, it begins transmitting data. In the example above, you can see the decimal value change as the weight is distributed to different parts of the foot. The range of the analog signal is between 2 to 3.6 volts. These signals are converted to a decimal value that's between 0 and 573.
The data analysis portion of this product takes the raw inputs and converts them into something meaningful. Take the raw inputs and turn them into colors to output to a visual to the app. I determine if the user is sitting, standing, or walking, and then I compare the state to the correct foot matrix for that respective state, and then I output that to the app. This is the color matrix function. As you can see, I take in the raw input values and I sort them via range from blue to red. This is the input and output of the classifier. As you can see, these raw numbers are walking and sitting, and they output as walking and sitting. And to compare if the posture is correct, I check if the foot is top-bottom balance and left-right balance. For walking though, I only compare left-right balance because when you're walking, it's either weights all on the heel or all on the toe. And that's all.
Howdy, this is Jason. I'm in charge of the cell phone app. There are 3 steps on the cell phone app. First, take the sending in data. Second, send the data into data analysis. Third, write the output of the data analysis into a heat map. Here are 6 dots on the heat map. Each dot indicates into a sensor as a sensor on the insole. Every time we press on the sensor, and then the color changes. Blue means no weight, green means heavier, yellow means a little bit heavier, and red means super heavy.
With everything coming together, we see the phone app on the right connected through Bluetooth to the smart insole, and when Jason presses on the heel, we see there's an indication that weight has been applied to that sensor through the app. Thank you for watching our Smart Insole project video.